Okay, on this presentation, we are going to take a look at GR2 interrogated thunderstorm cell that has some bad signatures in it. We're going to decide whether or not we want to issue a tornado warning or not. This is part 3 of our interrogation of the Nashville tornado, the EF3 tornado from the 3rd of March, 2020. And we're going to further our verification technique here. In part 2, we determined we needed to have the tornado warning out, and we did see some debris ball and tornadic vortex signature, so TDS and a TBS and a hook echo. So those all should stand alone on their own as a good verification, subjective verification technique. So if we didn't get the report, and the report ended up being just along the east side, east-northeast side of Nashville here, just inside of our 5 nautical mile radius. And that's, taking a step back here, that's our Nashville 5 nautical mile range ring there. And there's 10. And there's 20. So at this point, we are looking at 24 after 0624, and the event happened at 6:41, so 17 minutes prior to verification. And at this point, the hook echo, the hook had more or less kind of disintegrated, but it looks like it's coming back and regrouping a little bit. And we'll go ahead and bump it forward a couple of frames here. So we get up to about 630 Z. There we go. And this seems to be when it regains a lot of its coherence there. We're going to go 4 panels. And I don't have that set up yet. Let me get that going. So we'll put this ZDR in the bottom left, CC in the bottom right. And there's no specific pattern to this. I just like them set up this way just by virtue of the fact that's how they run in the columns over there. So base reflectivity in the top left, SRV in the top right. And we're using the severe thunderstorm warning box at this time. So at this point, National Weather Service had not reissued yet the tornado on this storm. So we're going to hopefully get the jump on it here a little bit. So this is 11 minutes prior. So we're going to take a look and see if our debris ball shows back up. So we'll get zoomed up here a little bit. And this is about the spot right here. We're going to want to be seeing our depressed areas of ZDR and CC, my little red marker right there. So initially ZDR is showing 1.9. Ideally, you want to be a less than 1 and preferably in the negative range. So it's dropping, but just barely. There's 0.94. And we're not really seeing any CC values yet. This like wedge shape right here, or triangle shape chunk of lower CCs, that's associated with the inflow notch. You're almost always going to see that, or typically that's where that's going to be located. So there's our inflow notch, and you got that kind of wedge shape to it. It's the updraft's pulling the right rear flank updraft, pulling all kinds of dirt and dust and bugs into the inflow notch there. So you're always going to see depressed values there. So we're not going to use that as our debris ball for sure. So now we'll step it ahead another frame or so. Here's 630, 632. Now the second frame here, we'll notice, let me back it up. There we go. All right, so this tornado report should have been at 632Z. Some kind of problem with the report. Reported it an hour earlier. There was nothing even close to this area at 532Z. So this is a 632Z report, 7 miles northeast of Pegram. And that lines up pretty well with this this as our hook. And I talked about it kind of regrouping. Well, it's at the point where it almost looks like it's occluded here. Your updraft would be there in about a weak echo region. So that's going to purge. So I can't leave it on the screen till 632 because as soon as I step it forward 1 frame, it's going to get purged because it's going to be older than an hour. So you won't be able to keep it. So this is 632 product time right there. So they must have used the radar position to verify that, or to position it. But something happened with the time frame. I'm not sure. So at this point, our debris ball should be sitting about right here. And once again, we got some lower ZDRs there, less than 1, and ideally want to see them down in the negative range. But our CC values aren't low enough yet, so still in the 90s and above. So good velocity rotational couplet there, cyclonic couplet, but it's out in the inflow notch. So this is probably a good example of some side lobe contamination. So big strong meso in the mid levels, and I think on the last part 2 we looked up to around 6,000 or 7,000 feet and started seeing a really strong meso at that point. So it looks like this is a reflection down in the inflow notch there due to some anomalies. So here's 635. We're really curling that hook up there really good. There's rear flank downdraft, right rear flank downdraft. And let's take a look and see what our values are now. So we do have, we're in the negative, so ideally that's where we want to be. Nashville Weather Service now has tornado warning out, and there's definitely less than 80%. That's your non-meteorological signature on CC is less than 80%. And once you start seeing 0 and less than 0, you got vertically oriented targets in there. So shingles, pieces of siding, you name it, things are getting lofted into the beam after touchdown, and that's only at about 1,000 feet roughly, or a little less. So it shouldn't take long to get that up there. So now what we want to do is we want to take a look at that and see if we can see that debris ball in the vertical using our cross-section method. So let me zoom out just a notch or two here. And we'll throw, here's your cross-section tool. And the radar's up here. I'm going to kind of want to run down the radial, or close to the radial as I can get. So something along these lines right here. And there's our reflectivity. So we're looking, there's Nashville. We're looking west to east here. The radar's over here on the right. See the radar area there. We've got the cone of silence. And here's our strong tilt. This is kind of a mini supercell, topping out probably at or below 30,000 feet, but this is still pretty early in the year, so that's real typical to get cool season mini supercell. So ZDR, we're not seeing a real good returns there, plus it's spotty, but look at the CC. We've got a nice little plume here. Let me slide this around a little bit. We should be at 635, not 630. Step it forward one. So there's the CC plume. There you can see the blue. So it's starting out here, getting lofted up to around 15,000 feet. So that's a pretty significant plume of debris there. And there's our ZDR that lines up a little bit. There's some negative, kind of fits in there pretty well. We were on the wrong frame there when I started out. Sorry about that. And so this is good verification technique. Use that debris ball. Let's see what the National Weather Service says on their warning. Reissued. Tornado watch is still in effect. Damaging tornado. Oh, this is not radar involved. The National Weather Service employee confirmed a tornado on the ground. So flying debris, deadly to those caught without shelter. So once you see the debris ball, the language changes in the reports. They become much more confident and insistent about a tornado on the ground, and there is debris, and that causes a lot of injuries and damage. So good intentions there on the warning to point that out. Let's go ahead and step it forward another frame. And we're seeing reflectivity showing a debris ball too as well, over 70, right at about 70, just under 70 dBz. We'll shoot another cross section through there. Nice if we had the dual pole on the velocity, or rather on the volumetric section, but that is not a feature we had on there. So let's try this again. My angle is a little bit, let me shoot that again. More like this. Still not where I want to be, but close enough. All right, so that's it. 36 after, 38. So there's our rear flank downdraft right here. And CC still plume. Not quite as high We are entering into the cone of silence there, but it looks like the vertical extent's not quite as a little stronger or a little more evident returns there with a little bit lower CC. It looks like a little darker blues and CDR lining up in there as well, right here for our low ZDR. All right, so that's our cross-section interrogation tool there for our velocity. You can take a look at that as well in the cross-section, SRV. Now, this is a little more difficult to use and not always productive, not always efficient to use the cross-section for rotation. It's kind of hard to detect, even if you hit the thing just right. Once again, just like with the CC, you can get a kind of an instant vertical extent on your evaluation of your vertical extent. So I'm going to turn off the storm report. So there's the report 641, and there's another wind damage, I think, at the same time, 641. So I'll turn this off for a second. Get it zoomed up again. A cross section up there. We don't get a cross section right at 41, so we'll have to settle for 43 after here. Let's see if we're still in that. Yeah, there's our debris still off there. Okay, and that concludes this part 3 of the Nashville EF3 tornado. If you have any questions, please feel free to leave comments, and don't forget to hit subscribe. Thanks a lot. Please go ahead and watch part 2 and see how the rest of this plays out. If you have any questions, just leave comments, and don't forget to hit subscribe.